this. C++ code smells. This is the talk you're planning to come to, I assume. My name is Jason Turner. If you don't know who I am, I'm host of CppCast, co-host of CppCast, which is a podcast for C++ developers. We're on 214 episodes now. And C++ Weekly, my YouTube channel, I just published episode 184, I think, so 184 weeks straight of doing YouTube videos. And I am a Microsoft MVP. I do training and contracting, and this is my life, so this is my sales pitch for myself here. If you don't know this, you probably want to be closer to the front so you can be more engaged. You don't come any closer. It's close enough up here. Please interrupt me and ask questions. I feel a little trapped on this tiny stage. We'll see if I escape from it, depending on how the talk goes, but I'll try to not give feedback into the PA like I did a minute ago. And this is approximately my training looks like. I do still have a constexpr class coming up on Saturday. If you are interested, there's still time to sign up for it. All right, talking about code smells, I'm going to start by talking a little bit about best practices. The core guidelines have about 496 items in them. Who has read all of the core guidelines? Well, yeah, a couple of usual suspects in the room that I recognize, but other than that. Effective Modern C++ by Scott Myers has 42. That does not include Scott's Effective C++, More Effective C++, Effective STL. I think those are all 4 of his most popular effective books. I have a C++ best practices website. If you didn't notice, there was a link to it a couple of slides ago. It's cppbestpractices.com. It's just a forkable GitHub coding standards document. I've got like 109 things up there. C++ coding standards from Herb Sutter, Andre Alexandrescu has 101 items. What's that? Oh, the coding standards? I agree, it is old, it's from 2000, however, there's still a lot of interesting information in it. I still like the book. So, just from these 4 items, I have 748 approximate best practices. This has questions. How many of them are unique? Does anyone know how many unique best practices have been published about C++? I don't know. How many of them are actually how many are important? I mean, how many really affect the way that we write code and we have to keep in mind all the time? Which ones can tools tell us about? All kinds of questions. Herb at his CppCon 2018 keynote said, we don't have to teach things all compilers warn on. Part of that problem is getting people to use their compiler warnings too, though. All right, code smells. I asked the question to myself, is it possible to swap these things around and instead of saying I have 700 rules to apply, look for just a couple of things that are smells that help me apply the other 700 rules. We're gonna see if that's possible. Do the smells help us reduce the set of best practices? Okay, I asked Twitter for their favorite C++ code smells. This is where some of you will see your own names come up in a moment. What do you think of this code? This is interactive, remember? Go for it, Ben, yell something out. Ben said it has a split between declaration and initialization. So I'm just going to click on this and just demonstrate because I've got Compiler Explorer integrated in all of my slides. This is with 03, C++ 17 mode, the latest GCC that's been released, 9 point something. And let's just say for the moment, it generates code, okay? This is not going to be an exhaustive assembly language talk until later, maybe. Okay, construction and assignment. I had construction separate from assignment, quotes Ben Dean here. This was This was Ben's response on Twitter, in fact. So he's right here to give us the live version of it. Now, anyone tell me what's going to happen if I look at an optimized build of this code? Absolutely nothing. Can someone tell me like why we expect most compilers can optimize this? That's, well, wait, who said that? Okay, I'm breaking out, sorry. What'd you say? It doesn't affect anything outside the function. That's a little bit, yes, that's true, but what might it have affected outside the function? Global side effects of like heap allocation, for example. Small string optimization is what we've had here. Small string buffer is coming into play, which is why it's not doing a heap allocation, which is why we see it optimizing it away. Clang would still optimize it away regardless. Okay. So that's the first smell, or the first, smells construction separate from assignment. Now what do we think? I'm using output parameters. That's what I'm looking for right there. Sorry, I heard the parameter's not const. We'll come to that in a moment, but I just waited a minute to see if I heard the answer I wanted to hear. Okay, so I can swap this around. Yes, Oliver, sorry. Just got a t-shirt because of this. What's that? Ollie just got, okay. So this is output variables. This was his code smell. Quick question, how many parameters does this function take? What? That's not a very clear answer. Yes, go ahead. You have to yell, your hand was up, just yell. No, are you in front, yes, you. An undefined what? How's it an undefined number of arguments? What am I missing? Yeah, the declaration is right there. Oh, okay. Can anyone give me a specific answer? One parameter. What is that one parameter? That is the return value location, or the memory location for that function to go. I lied when I said we're not going to talk about assembly. I'm sorry. But it wasn't intentional, I promise. Right here, I am setting up a place on the stack right above that for the string value that's going to result from this function. I'm saving that in the register RDI, and the 64-bit calling conventions here, RDI is the first parameter to the function. It has an unknown, hidden first parameter. That's the location the string's going to live in. Okay, output variables, or out variables. There's also a recent-ish article the last few years from Sean Parent on stop using out arguments. Here, you can go and read that if you would like to. I think you know the rules already to start yelling stuff out. Yeah. What's that? You would like to use an algorithm on the vector. Yeah, I would agree with that. Does anyone else agree with that? No raw loops, raw loops. So a raw loop is the code smell we're looking at here. Sean Parent, he didn't actually say this on Twitter to me, but raw loops don't express our intent, algorithms can. Now, I know that this code right here on line 12, some of you might think it's insidious and some of you might love it. Who says this is terrible? Ooh, I'm getting people I know saying it's terrible. Who loves it? Okay. All right, that's cool. It was more. Yes, Ben. Okay, Ben wants me to use cbegin and cend. That I will not argue with. What's the in-between comment? Yeah, no, I mean, but where do you want to make a comment as to what you don't love or don't hate? Okay. To me, the power in this kind of expression is being able to read it. Are all of them in the range? Everything from the beginning to the end in range, right? Like, that's what I love about it. Does anyone who hates it want to comment? Yeah, go ahead for it, Jan. Okay. So you don't love the fact that we don't have C++ 20 ranges yet. Is that what you're saying?
I'm not sure. I don't like the range. I don't like the view.
You don't like the begin and end, is that's what you're saying you don't like. So if I could just pass in the values to the olive algorithm, then it would be awesome. Okay, C++ 20 ranges, we'll get there soon-ish. What year is this? 2018, 2020, then. Who is using C++ 17 currently at work? Okay, let's do this now slightly differently. At what point were you allowed to start using C++ 17? So I don't know, how do I do this as a group poll? Did you start using C++ 17 this year? Did you start using it last year? The year before that? That would be a little bit harder, but possible. Okay, so it sounds like a lot of you in here are actually pretty able to stay close to the top of C++ standards. That's cool. So maybe perhaps in 2021, you will be able to use ranges at work if your company keeps up on the standards. So, raw loops, Sean Parent. Yeah, I put those in a function, you can give them a name. I am not going to argue with that at all. Ooh, someone just said bracket access. I wasn't planning to talk about that at all. Who said that? Okay, why did you say it? Unintentional writes as a result of bracket access. You know what? I would say that's possibly true because in this hypothetical code, those pipes and hoses are member variables, and I didn't make the total area member function const. I really should have. I didn't even think about it when I wrote this example. Yeah? That's an interesting point. Oh, did you not like that part? Oh, okay. So, I'm sorry, for the camera, that's hose radius times pipe radius, that one right here. Yeah, which can be solved how then? Using a function, okay, let's go ahead and, yeah. So that's a bug. Let's decompose this into functions and or lambdas. I don't care. Lambdas are awesome, right? Who says lambdas are awesome? Are they your favorite feature of C++? No? Yeah. All right, so lambdas are awesome, but not necessarily our favorite feature of C++. So I can, make this into, total area plus total area, something like this. Multi-step functions. This is actually what I was getting at here, is this step 1, step 2, step 3, step 4. There's Tony Van Eerd tweeted about this, and a bunch of people responded to him on this, and other people are like grepping their code. Do I have anything that says step 1 anywhere in my code? Because if you do, it probably needs to be multiple functions. Wait, what's that? Value is int. We're not there yet. All right. On that one. Yes, value is int. Does that bother you? What is the type of pipes? What is the type of hoses? You don't know, right? But I multiply it by pi. Maybe it's a very inaccurate, no, yes, okay. Yes, value is an int. We'll come back around to that in just a moment. Okay. Are comments necessary in this code? Does anyone want to take a dissenting opinion and make your stand? What's that? You might have new employees. Now, I've actually, well, someone who's in this room at the moment took one of my classes and said, if you think that a comment is necessary, that means you didn't name things well enough. And I don't know if I agree with that 100%, but I'm very, very close to agreeing with it. So you could have potentially named things better if your new employees might be confused by this code. What's that? I am not going to say out loud on the record that comments are a code smell, but they might be. Okay, so the comment, I know this quadrant heard this, was the default reference capture is definitely a code smell. When does it matter? Is it asynchronous functions? Okay. It matters when the lambda escapes past the lifetime of the object that you captured. I am calling this lambda right here in this function. It's a good point. It's a strong point. Yeah, no, that's a good point. In this example, so I actually had this example written differently earlier, but I separated it out. If I put this lambda called accumulate area inside this lambda called total area, the only reason I'm capturing it all right here is to capture the other lambda. I could have captured it by value, actually. It would have had the exact same effect because that is a stateless lambda, and it would have been fine. Or I could have defined the lambda inside the other lambda, and it would have been equally fine. Or I could have moved any of these out into named functions to solve that problem, but it's a good point. I could use transform reduce. Know your algorithms. Okay. I'm gonna move on from that because I'm spending perhaps slightly more time than I meant to on it. Multi-step functions. Bjorn, not here. Tony is not here. Is Peter in the room by any chance? Peter Summerlin? No? Oh, they don't get to shout out any shout outs here. Okay. Ooh, you wanted a free comparison operator. I'll give you that one, but it's not what I'm going for. I'm missing at least one const. How many consts? 2. Okay. Oh, just for the record, by the way, like all of these examples are based on code that I've looked at in recent memory. So it's not just completely arbitrary examples. Spaceship, yeah. In 2 years, you get to use spaceship. Okay. Const member function, const values, a comparison operator. This is const. We're not mutating our objects with comparison operators. Non-canonical operators. I realized like 5 minutes ago that I should probably have numbered these. Sorry. Okay. Going back to this one, what was the shout back there? Our value is integer. That's one problem. What other problems do I have? No, I fixed that on this slide. Yeah, sorry, yeah. What's that? MPI is double. Yes, no, so we know that, yeah, so value is an integer. Those should all be doubles. But there's another problem besides the values in the radii and the pi. My index type is an int. Just out of curiosity, does anyone actually work on data sets bigger than 2 billion items? Yes, Bryce does, no question. There's a few in the room. Yeah, it's real. Yes, it's real, right? I work a lot with a company that does database systems. They're like 2 billion, that's nothing, right? So those should be size type. const string to const car pointer back to string again is the conversion I'm doing here. Yes, I'm forcing a copy of the data, but even worse than that, I also have to call strlane to see how long the data is because that information got lost. You could actually step into this and see the call to strlane if you wanted to, but let's not do that at the moment. I am making a strong statement here. I say this always exists in code that has been refactored over a long period. What's that? You want a warning to catch that. We'll come back to that. Anything else? I know that I am making the camera crew's job more exciting. Yeah, I don't know if I'm gonna. What's that? Should I use string view? Maybe. I definitely don't want to be doing this conversion back and forth. I would say the call to C string is a bigger smell, but either way. Ooh, yeah, I could do that. Call get string in there, yeah. Yes, okay. We can pick apart. It's amazing. I did a live code review recently as a part of a user group meetup, and we couldn't get past the first 4 lines of the, it was a thing. Anyhow, who can tell me what standard move is? It's a cast. It's an unconditional cast. Someone said to what? To an R value reference. Okay, unconditional reference, a cast to an R value reference. You're being intentionally difficult in the front row. Okay, unconditional cast to a string R value reference. I just eliminated our, yeah, what were you gonna say, sorry? Yeah, short, it is a long string, intentionally. Well, at least on some versions of standard string. Yeah, so I'm forcing a move instead of letting the compiler do its RVO. Is that also what you were indicating? You're saying the move is expensive because sort string operator. I don't think is the smooth any more expensive or less expensive? It's a small string. I'm gonna ask a standard library implementer in the front row. What's that? It has no relevance here, whether or not it's, okay. Good, the definitive answer. So this is our pessimizing return by move, prevents move illusion, move prevents RVO. So, I'm talking about code with conversions at the moment. I kind of glossed over that topic. Standard move, this is another type of conversion that is a code smell. Huh? Why? I am making a general statement that move is a code smell. Yes, I am. Yes. There was a talk not given by me that was called Nothing is Better Than Moving. It was last year at CppCon. And I believe the point is doing nothing is better than moving. Yes, okay. Guaranteed copy elision is not applied. This breaks guaranteed. Guaranteed RVO isn't 17. It's only guaranteed in the case that we initialize that value in the return statement. So your coworker says it's not guaranteed, so don't return by value, and your coworker wants to return by move instead? They're always wrong. No, they're not always wrong. I actually have some examples on Friday where they're not always wrong. But these kind of examples are trivial to pop into Compiler Explorer and show, ooh, look, it's doing more work than it has to. We'll get to that. I won't repeat what you just said. Okay. Real quick though, what's returned from this function from main here? Doom. Ooh, I think I knew that better. Doom. No, okay. So doom is returned. Does anyone know like what your compiler is actually gonna do here? Anything? All that I am aware of will do this. So you're assigning 13 and it just returns 4 because it's allowed to take that const int and assume that it's const for the rest of eternity. That value doesn't change. So 4 is in practice returned, but in reality this is undefined behavior and the compiler catches on fire and it's bad. So modifying const object during its lifetime is undefined behavior. Const cast is another explicit conversion that is a code smell. Weak typing. So Arna tweeted this out, and Matt yeah, the which int is which interface, right? When we're calling socket, do we know which one of this is? Is it the domain, the type, the protocol, right? This is not pleasant kinds of APIs to work with. So, code with conversions. This is the code smell that wraps up the last thing. Implicit, explicit, cast, I'm including move in that for the moment. Well, I'm including it, but believe me for the moment. Can our compilers warn on this? Yes, if we turn on our warnings, right? So we can get warnings here on loss of precision, hopefully. Just for the record, who uses Visual Studio? Oh my goodness, that is a high percentage. Who uses GCC or who uses GCC exclusively? Okay, you have a lot of warnings to turn on. Because GCC is the worst about warning on a lot of these loss of precision kind of things. Visual Studio, in my opinion, is the best at it. Can we get a warning here? What's that? Yes? I'm getting some thumbs up in the background. What did you say? Yeah, Clang can warn on it. Which warning specifically are you referring to? Yeah, okay. So, I don't have it spelled out here. We can definitely get warnings from our tool chains on here. Clang Tidy can definitely warn on this. Pessimizing move, right, that one. Okay. So, code with warnings, this was Bjorn and Dimitar Mirchev, perhaps, commented on code with warnings here. What are the implications of putting a static variable right here, the static string function name? There's a guard every time we go to access this. It's a magic static. C++11 guarantees that these things have to be initialized in a thread-safe way. Since all of you raised your hands that you are both Visual Studio programmers and you're using C++17, that means you all also have this feature. If we actually really wanted to walk through this, we can see it here. We can see that there's a guard variable. We have to do a guard acquire every single time we enter this function. Or, well, not a guard acquire. We have to check to see if the value has been initialized, and if it has not, then we have to come down and acquire a lock guard so that we can initialize it. Then we have to release the lock guard, otherwise we have to jump over that code and exit from the function. It's not free. Each time, yes, that's what I just said. Compared to this, now I cheated a little bit. I got a question about string view earlier, but if I'm just logging errors, string view sounds pretty good. That sounds like something that's observing a string-like thing to me. So I can use a constexpr static string view here. Now what work do I have to do whenever I enter this function? I never have to reinitialize the string. No, it's static. Yeah, so this is a static string view initialized with a character literal. That character literal is guaranteed for the lifetime of the program. This is going to be initialized at compile time. We're not going to see really anything that has to happen here. I'm just making sure. I'm getting nods from a couple of people because I'm like, wait a minute, did I just miss something? No. What was that? Okay, so logically speaking, the question was any advantage to dropping or keeping the static? Logically speaking, this is static, right? We only want one value of this thing. So I think, let's just say it's static. Practically speaking, if we don't make it static, many compilers actually, well, this is a string view, so it's not a complicated thing. But if it were something that actually performed a calculation, many compilers would actually reinitialize this value, even though it were constexpr, on each function call. If we make it constexpr static, they won't. So it's more logically correct, and it is going to gain you something. So this is my next code smell here. Static const is a code smell. It should probably be constexpr. Not everything can be constexpr. You should come to my class on Saturday. No, not everything can be constexpr, but most things that are known at compile time, static const is likely something that can be calculated at compile time. There's a very, very good chance it can be made constexpr. It might take more work than you want to, but it's a very high probability. Initialize it somewhere else potentially, yeah, so we don't have to do this, yeah. So I saw this code recently, greatly simplified into 3 little code blocks. I'm going to simplify it one step further and just look at this. This is what the compiler sees when it compiles the CPP file. It can't be in the value, well, the value can't be inlined is more to the point here. So this is, sorry, camera person, I'm walking around. It's kind of like I'm telling the compiler, I have some really important information for you, but I'm not gonna tell you. Right here, whenever I go to access this value, I have to go look at some memory location and say, what is this value? It's a const integer, right? That is known at compile time in this code. It definitely was in this code, just for the record. In some code, it's not. It's known at link time. I'm telling you, in this code, it was known at compile time. Okay, better option. Static const in the header, or constexpr. Compile time constants, constexpr. Extern const often can also be constexpr. All right. Yeah, manual memory match, I'm calling new. We don't like that. Raw, new, and delete, I can use make unique. This is, of course, wasteful, and the heap should be avoided if at all possible. Just needed to throw new and delete in there. So far, my code smells. Construction is separate from assignment. Output variables, raw loops, multi-step functions, non-canonical operators, code with conversions, including move, casting away const, code with warnings. Actually, I just was in Billy O'Neill's talk, and he was talking about casting away const in some, wow, really bad ways. Static const, extern const. So he was talking about bad code that other people had written, not code that he was advocating, just for the record. Raw, new, and delete. Now, this does not cover everything, right? I said we were starting with 478 things. I see lots of you taking pictures. We're not to the good stuff yet. Okay. Let's do a quick code review. What do I do? What was that? Sorry, you're gonna have to like yell. Using namespace. Okay, let's get rid of that. Initialize length. Now, I should point out just for the record that this code is meant to be learner's code, so we still want to leave the addition of the two strings together, right? Like, this is just code about learning how to use string objects. Okay, what now? Const everything, I just heard. And I don't know, just to satisfy like a third of you, I'll do this. Yeah, what was that, Bryce? The include, yes. It's got the wrong include here. Let's do that. GCC's, their headers aren't terribly clean. Including IOStream picks up string. It really, I mean, was there a warning from it? Oh, there is a warning. Oh, okay. That also could be const. Okay, what should the type be? Oh, yeah. We're going to go for the technical answer. Yeah. Okay, who prefers stood string size type? Who prefers auto? Who prefers size T? All right, auto wins. Okay, what's that? Maybe unused, yeah, I mean, yes, you're right. We could, yeah. That's silencing the warning. You stood size, ooh, you know what, I'm not, you're just gonna make me run out of time, and I'm gonna blame Ben, and it'll be on the record that Ben is to blame here. Size. I am not in the habit of using the free function for size, personally. I am for begin and end and many of the other things. Oh, Bryce doesn't want me to do this. Ben, justify yourself. What's the advantage? Do you need a mic? Oh, he's not gonna justify himself, okay. I honestly don't have an opinion. Stood size? What, wait. Yes, so if you're writing generic code, stood size would work in this case, yeah. Okay, I'm gonna move on here. We ended up with something kind of like that, I think, except the IOStream header. Oh, and then using namespace, all right. Stood in line. Oh. You're saying here. Yes, I'm gonna agree with that. That's a surprise that I agree with that, right? Okay. Oh no! See behind the curtain. Okay. All right, what else? Transform. I mean, I'm calculating a factorial. I don't know if I can. Okay, so I could use accumulate or transform or something to generate this. I'll accept any of those answers also, though I don't think I'm gonna take the time at the moment to type them in. What's that? Declare the variable, oh yeah, declare the variable inside the loop. Right, okay. You're saying like that. Okay. Ooh. Okay. The actual comment was I don't need to return from main, so I just decided to be explicit about the meaning of the return value. Okay, I mean, is anyone gonna suggest like maybe a factorial function as a hypothetical possibility here? You wanna use big int, is that what you said? Yeah, I mean, factorial could quickly blow up. There's a hand way back there, huh? Oh, were you just scratching your head? Okay. All right. Okay, not to pick this apart line by line, but you know, maybe I ended up with something kind of like this. So I've got a read input function, I've got a factorial function, and now I can initialize my variables when they're declared. I can read the input. In this case, I made it generic. I could have done whatever. And I have a factorial function, so I can initialize the factorial variable, and then I can print this out, and I can return a constant with meaning. Is that okay? The code's longer. Yeah, go for it. Yes? Oh, if you wanted to read multiple variables. So you're saying if you did like cin, extraction operator, value 1, value 2, value 3, value 4, I don't honestly think that that would be more or less efficient than this, but I've never measured it. I don't think cin is the paragon of reading efficiency in the first place. Yes, Renee, was it?
You're not sanitizing the input or checking it anyway?
I'm not, yes. And yes, in no way is this code sanitizing the input or checking it. That's true, yeah. But is that a C++ code smell, or is that just a generic code smell? Yeah, programming smell, yeah. I'm just coming back there, yeah. I'm just keeping it exciting.
How about in the factorial function, instead of the raw
Instead of a raw loop, creating a range of 1 to 10 and then accumulating, or 1 to n. I think the problem with that would be I'd have to store that range somewhere, and that would likely involve a heap allocation or something that is unnecessary for the sake of this code, unless I am missing something. Unless I did a generator. What's that? Use iota. Ben says use iota. Yes, we could do that. Okay, I didn't need to reload that page. We had not done anything with it. What are the conclusions that we've come to so far? It's one thing that keeps coming up that hasn't really been explicitly mentioned. I'm gonna walk through these, review. What do you see here? Const. What do you see here? Fewer lines of code, yes. Const what? Better syntax highlighting. There's nothing to syntax highlight on the first block. So more keywords so that your code is more colorful is better code. Smells good, okay. Const. What do we see here using the algorithms? More readable and more constable. Is that a word? Is that able or ibble? Constable. More constable. So, what kept coming up? Const. It's not like this is the first time that const has ever been mentioned at a C++ conference. Now, this, I don't know if this is going to work because, is this mic hot now? Can you make the podium mic hot? Sound engineer? Okay, it says it's hot now. I'm gonna try to not get feedback or anything. Is that? No, it's not happening. Oh, hold my mic up to it. Oh. Okay. I'm just gonna stop here, that's all right. So this is Kate Gregory at CppCon like 2014. The first CppCon, she did a talk with James McNellis, and she's saying, don't const because you have to. Const everything that you possibly can. And the compiler becomes your friend. So you're going through, this is constifying, this is moderning legacy C++ code. They go through, and she advocates making every single variable const that is possible to make const. And then the compiler checks you when you're modifying things that you shouldn't be modifying. Yes. Yes, she did say last year also, make everything const and then keep removing const until it compiles. That's starting with legacy code base. I also have a little snippet here of myself from my first major CppCon talk where adding const makes like the entire program go away because adding const on a static global variable let the compiler put it into the read-only space of the binary, and then it applied a whole other set of optimizations to the code. Not the kind of thing that we can rely on. Const isn't about optimization, but it might get you optimizations accidentally. So const, any lack of const is a code smell. I'm gonna say that strongly, yes. Just a minute. Okay. Const forces us into more organized code. We're calling our algorithms, we're using functions. Const prevents common errors. Const encourages more use of algorithms. Sorry, I'm repeating myself now. Do you const value parameters? You're communicating with the other people. I get yes on the definition only. This, just for the record, is code that I actually wrote. Except I made count const, and it didn't compile. I got to the plus count, and I'm like, why am I getting a bill there? Oh. I have a couple of people agreeing with me here. I know full well if you go back to your companies and you say, Jason said, make all of my value parameters const, they will all shoot you down and tell you that I'm crazy and stuff like that. But I'm standing on this one. I am. If you use std move, then you need parameters that are not const. Yeah, maybe. But then you're doing something different. So if you need to call move on it, I didn't say never use const. I said I didn't say never use move. I said it is a strong code smell. If you need to move an object, then it can't be const. I know it does. It's wrong. Oh, sorry. The comment was cling tidy yells at you for doing that. I know, yeah. Like I said, not everyone agrees with me, although I am pleased with some front row agreement at the moment. Okay, do you const temporary values? This is my temporary value. Do I const this? All right, what about line 8? What is that? It's wrong. So I will do a temporary, well, there's no guarantee that any move is actually, temporary, no, it'll construct by copy in place of the parameter. No extra move will happen. It'll just be a copy here. Okay, so I'm applying const. Okay, so that reverts to a copy. Now I made it not const. I'm sad because I wanted to move it. How do I solve the problem? What's that? Like, just put it in the invocation. Solve the problem. Good for us. We avoid the temporary. We can write a function. Ooh, okay. Do I const returned objects? This gets tricky, and I'm running out of time. So Is this okay? Who says this code is perfectly fine and it does what we want it to do? Oh. Okay. Who says they think it should be fine, but they're not sure? Okay. Who says this is definitely terrible? Okay, quick, someone, definitely terrible, why? So it does not inhibit return value optimization right here. Now I'm gonna do this. Now I get no RVO and I get to construct two string objects whether or not I need them. If I do this, this, by the way, is implicitly a move. It's equivalent to doing this. This is a copy because it's const. This is a copy because it's const. So how do I resolve this problem? Don't use const. Wrong answer. Okay. I can still use const. I can do this. I get RVO in both of the code paths here. Or I can avoid naming the temporary altogether. This, by the way, I was building Clang for the fun of it before this conference, well, before the last conference I was at, just to like get a fresh build of a recent trunk build of Clang. And I saw this code come up repeatedly generating warnings. Clang, compiling Clang, was generating warnings on this code. Does anyone know what it is? That it was generating? Yeah. Redundant move is what it was actually called because it's a move. It says as C++ 11. Okay. Do I const value return types? No. Why not? Because what? Actually, okay, I got a few comments that say it does nothing, but now we have to clarify that. Okay, this, by the way, the question is, do I want to forbid this kind of operation? It's weird, right? I don't want to do that. But if I put const here, that now fails to compile. It's not allowed with built-in types. So if I do this, if I have a local string object s and I assign it, this is move assignment from the return value from this function. If I do this, it is now copy assignment because you can't move from a const value. It does actually change the meaning of the code. Of course, we can avoid this question altogether. We can use const. So it becomes irrelevant. It's still not a good idea, but it becomes irrelevant, right? I just said, wait a minute, that string s, that's not const. How do I make it const? Oh, I can make it const, and now if it's const, it doesn't even matter anymore. It's not an assignment anymore, so we don't care. So I found 3 smells. Missing and ignored compiler warnings. There are special checks for many of these. CppCheck helps us reduce variable scope. Variable can be const, can also come from various tools. I'm missing a quote, unfortunately. The core guidelines checkers will check us for raw pointer memory usage, pessimizing move warnings, const return values, and Clang tidy. Wait, who was it who said you want a compiler warning because of the string conversion? It was you, yes. So Clang tidy actually has a special check specifically for that case when you're taking a string and passing it as a C string to another string. So Clang tidy, use your tools. Yeah, this is the good stuff, by the way. Now you can take a picture. Missing const and constexpr or misplaced const. Why is that value or member function not const? If it's known at compile time, it should be a constexpr or enum. Make it a compile time constant. This forces us into more efficient organizing of code. If we know the size of a thing, and we want to make it const, or we want to make it constexpr, now we're using std array, which is amazing. We're using algorithms, we're using the numeric header. You have my little quote, just for the record, I am quoting myself down here. I don't care if you want to use east or west const. use const. And also, I'm not an almost always auto fan, but using almost always auto pushes us in the same direction of initializing our values and using const. Weak types and casts. Unfortunately, the C++ standard library doesn't help us here a whole lot. We have implicit conversions, helpfully, between string, file system path, const character pointers, string views. We've got implicit conversions into optionals, variants, and between shared pointer types and unique pointer types. Lots of non-explicit constructors and conversion operations in the standard library. So you can do what you can on your side. Use stronger typing. Rules 1 and 2 catch some of these things. Otherwise, you just have to read your code. Sorry. No, I don't have any slides for that, Jan. Oh, Jan, sorry. Well, okay. Maybe I will just go ahead and mention it. I don't have a slide for it, but I probably should have. Member variables should not be const. That breaks other things. So let's just throw that out there right now. I should have had a slide on that. I apologize. Member variables, not const. Remove that from your brain. We can avoid naming temporaries to avoid move. And I don't think I have time for the bonus code review a whole lot here, but go ahead, quick fire. I have like 2 minutes. Const reference vector, what? Next element? Oh, minimax element, yes, minimax element, and that's it. So I can just make my own algorithm, right? My algorithm is to return the range of values from here, the min and the max, or the range, the distance from the min to the max. I actually looked it up on a math website to make sure I had the term right for range. That's how I roll. Okay, so that's me. We have like 2 minutes for questions. If anyone has any questions, yell it out or go up to a microphone or just come up to the stage and join me up here if you want to. Why isn't const default? Yeah, historical reason. Yes, it is on lambdas. Lambdas get the defaults right. And then mutable becomes the smell. Yes, but we can't do it now. Why shouldn't member variables be const? Because there's weird lifetime rules that come into play that, like, if you change the location of a thing and it's bad, and then, I mean, it's, yeah. Anyhow, and then there's, it just makes your types much harder to work with than they need to be. You can't swap them, it's harder to use them in containers, you can't assign to them and that kind of thing. Yeah. All right, thank you everyone.